Hey, so there was a couple questions that people had about one of the homework problems from section 7.8. And in this particular case, as you can kind of see on the screen, it goes from negative infinity to infinity. In this case, I chose the numbers x to the 7th, e to the negative 8x to the 8th dx. So you may have had, for example, x to the 5th and e to the negative x to the 6th. It's always going to be one difference. It's always going to be an even power in the exponential itself. So with that in mind, I thought that since there were several people who had issues with it, I decided to do a short video here. The first thing that you want to do is, because this is an improper integral for both the lower and upper limits of integration being infinite, negative infinity and infinity, you need to split it up somewhere in the middle. In this particular case, it really doesn't matter because there's no other problems in the middle, which is usually what's going to happen. I can't think of an example that you would come across where it was a problem in the middle. And from there, what you should do is say it's 0 because it's easy. You're going to need to have two separate limits, one for each integral. So you might notice, for example, here I have a going to negative infinity and b going to infinity. A lot of times if you have only one, that's a problem. You might choose t as an alternative. I tend to like to use a for the lower and b for the upper. Then it's a matter of solving the integral, make sure to include the limit each time. This is a substitution, fairly nice one. As you can see, u is going to be negative x to the 8th. So that x to the 7th really isn't a problem. I know it's tempting to do integration by parts, but that's not going to work in this particular case. So once we do that and then integrate it, you can see that I already have pretty much what you would get at the end. You might include one or two extra steps, I don't know. So as you see it, we now come to what often is the trickier side of things, and that is how to take the limit. When you're doing an exponential, we talked about this in class, that it's often an uncertainty how you are going to approach that. So at this point, what you want to do, obviously the negative 1/8 is not going to be a problem. But this could be. The key here is that you notice a is to the 8th power. So even though a is going to negative infinity, it is still a negative. But because it's an even power of that, we know a to the 8th is always going to be a positive value. So a negative of a positive means overall the exponent is going to be a negative value. And the same thing is going to be true when we go to the b's. Now, the big difference here is a is approaching negative infinity, b is approaching infinity, but it actually doesn't make any difference when it comes down to it. It's only that it's infinite in some respect. So because this is a negative exponent, that means exponential decay, since we're approaching an infinite level. So that limit is going to be 0. When you take it on the other side, the limit is going to be the same way, again going to be 0. Add 1/8, and then what do you have? Well, negative 1/8 plus 0 plus 0 plus 1/8, and then what you get, is 0 overall. Imagine that. So after all that, so this is convergent. And what we can say is the integral from negative infinity to infinity of x to the 7th e to the negative x to the 8th dx is exactly 0. And that's our final answer.